In this video, we're going to explore conditional probability. Conditional probability allows us to calculate probabilities when we have partial information concerning the event of interest. So for example, suppose that I toss a coin, came up tails. Great. Now, given that the coin came up tails, what is the probability in, let's say, 3 more tosses that I'll obtain at least 2 heads? That's an example of a conditional probability calculation because the partial information concerning the event in this case is that I obtained a tail on the first toss. Suppose that we flip a coin 3 times. What does the set of all possible outcomes, the sample space, look like? One possibility is 3 heads in a row. Another possibility is 2 heads followed by a tail. Yet another possibility is head, tail, head, and so on. In fact, there are a total of 8 possible outcomes. What is the probability of obtaining at least 2 heads in 3 coin tosses? Well, there are 8 possible outcomes. Among the 8 possibilities, which outcomes have at least 2 heads? Well, you can see that the 4th outcome only has 1 head, so let's eliminate that. And you can see that the 6th outcome also has only 1 head, so let's eliminate that. And same with the 7th outcome, it only has 1 head as well. And the 8th outcome has no heads. So let B be the event of obtaining 2 or more heads. Then the probability of B is the total number of ways that B can occur, which is 4 in this case, divided by the total number of possible outcomes, which is 8 in this case. So far we've looked at the probability of obtaining at least 2 heads in 3 coin tosses. But now suppose that we had some partial information concerning the event. What type of information could we have? Well, let's suppose that the first toss came up to be a head. Now we're going to explore how to update our probability calculation in order to incorporate that information. In other words, calculate the conditional probability of obtaining at least 2 heads, given that the first toss came up to be a head. Now suppose that we learn that the first toss is a head. What is the probability of 2 or more heads given this information? Since we are given the information that the first toss was a head, we can eliminate all the outcomes where the first toss was not a head. Among the outcomes where the first toss was a head, these 3 have at least 2 or more heads. The notation P of B with that vertical bar, A, is read as the probability of B given A. In our case, this is the probability of 2 or more heads given that the first toss is a head. There are 3 possible ways for 2 or more heads to occur given that the first toss is a head. So, the probability of B given A is 3/4, or that is, the probability of 2 or more heads given that the first toss is a head is 3/4. This leads us to the general definition of conditional probability. The general definition is encapsulated in this formula. The probability of B given A is equal to the probability of A and B divided by the probability of A. In this case, the event A gives us partial information about the event that we're interested in calculating the probability of, which is the event B.